Hello, welcome to my channel. I am the Pascack Tutor specializing in math and science. I am a certified biology and chemistry teacher with many years of experience teaching and tutoring. If you are looking for help with any of these subjects, I can meet you in person or check me out virtually the way you're seeing me now for $40 an hour. Virtual tutoring, best deal in the entire country. Certainly in Bergen County, where I am, the northeast corner of Bergen County, just about 6 miles from the Hudson River. So let's get back into it. I just covered ions and how to determine the number of electrons with ions. You can check out that video. It was the last video posted. Now we're going to cover isotopes and determining the number of subatomic particles with isotopes. So we had this example here with sodium, and I was going to come up with an example for sodium. So let's get back into it and cover that now. Take out our periodic table. I'm going to make up the numbers for this one. Look at sodium. I'll make up a number like, let's go with sodium 24. So let me write the symbol here, Na. We already learned in the previous video, when you see something positive or negative above to the upper right, you know that you've got an ion, and that means you changed the number of electrons. Well, when you see something like this, like sodium-24, or sometimes that's the example I'm going to make up right here, or sometimes you'll see it written like this. You'll see an Na with the 24 up to the left, and then 11 down below, like that. So these are two different ways of writing isotopes, or they'll just write sodium-24. So these are two ways to write it. You'll either see it with the symbol, a number up above and a number down below, or you'll see symbol or a name dash a number. And that number is always the bigger of the two numbers. Now, you have to know a little bit about the periodic table in order to determine what's going on here. Well, look at the periodic table and you could see a match to one of those numbers in our example. Here's sodium, it's number 11, it's got 22.98 below it. So what is this 11 referring to? That's right here, it's this number. It's the number of protons. Remember, the number of protons never changes for an element. So that 11 is specifically referring to sodium. Okay, so that's what you see there. You notice the 11 doesn't show up here. So that bigger number, you got to come to grips with what that bigger number is. That bigger number is the mass number. Remember when we take this atomic mass and we round it to the nearest whole digit or make it an integer? It becomes known as the mass number. So 22.9 rounds to 23. And I think we did that in the previous example. Yeah. See, there was no other numbers here other than a charged particle. So we had that number from the periodic table, 23, and we were able to use that number to determine the number of neutrons. Well, when you see something like this, 24, or a big number up here, that's referring to an isotope. It's different. It's a different number than the one you got off the periodic table when you rounded it. So now that's the number you're going to use for this column to determine the number of neutrons. This is essentially what it is the mass number. So an isotope is an element that has a different mass from other versions of that element. You see this one up here, sodium, we didn't write sodium-23, although we could have, but when we don't write anything, that means go to the periodic table. When we write something after it, that means it overrides what you see on the periodic table. That's a new mass number. So let's calculate the number of protons, neutrons, and electrons for sodium-24 is the way you would describe that or say that. It's sodium-24, or if written up and down like this, it's sodium-24. I kind of like when it's written up and down because this middle calculation is kind of easy because that's the way you would calculate. You take the bigger number, subtract the smaller number from it to get the number of neutrons. But anyway, So looking at this, you could either memorize that the bottom number is the number of protons, or you just go to the periodic table. There is no sodium that doesn't have 11 protons, so that number never changes. It was 11 back here with the ion. It's 11 here still. That doesn't change. All sodiums have 11 protons, always. Just like beryllium, all berylliums have 4 protons. That didn't change, even though this was an ion. So now, also, this is neutral. So once we know the protons, we can jump over to this column and do the electrons real easy. If it's got 11 protons and there's no pluses or minuses here, then it's got 11 electrons. The only thing an isotope is affected by, or the only thing that affects an isotope, is the number of neutrons. That's the only thing you could change to make an isotope. So we're going to take that 24, whereas before it was 23 because we got that off the periodic table, but now it's override. It's in override mode here. It's now 24, but it still has 11 protons. So how many neutrons does this have? It has 13. Notice that's one more than sodium 23 had. It had 12 neutrons. Sodium 24 has 13 neutrons. See how that works? Let's do another example. I got room at the bottom of my sheet here. Let's do one more one more example of an isotope. Let's see. Let's just do for the heck of it. I'm going to make this up. I don't know all the isotopes of chlorine. I don't know any isotope of chlorine. I'm sure there's one that's 35. There's probably one that's 36. Doesn't really matter for this example. I can make it up. So what if I gave you an example, and let's make a charged part. Let's combine two things. We'll make an isotope that's also an ion. So this is going to be challenging. You'll have to think a little bit. So let's make chlorine Cl -1, and I'm going to write it in the up and down mode here, and then I'll show it down below going vertically as well. Okay, so the small number's on the bottom. Where did I get that small number from? Well, every chlorine has to have that same number on the bottom. The bigger number is going to be some rounded version of this. Now you see, the periodic table says it's 35, so I'm not going to make it like 80 or something really far away. I'm going to make it something closer. Like, let's take some away. Let's make it like 32. Let's do chlorine 32. How about that? All right, here we go. And I guess if you were going to write this in a horizontal version, it would be Cl or chlorine -32. I've never really seen it. You know, I guess you could do it like that, -1 to show that it's an ion as well. Sorry, I'm running out of space there. But I'm going to go with this because I'm not too confident in writing it like this with the -1 and the -32. Looks a little wacky. So how many protons does chlorine 32 have? The chlorine ion that's also with a mass of 32. Well, what does every chlorine ion have for the number of protons? It's a unique number. No other element on the periodic table has any other number. You can either look at it right there on the periodic table, or remember, if you memorize it, it's down here. It's the smaller of the two numbers. The mass is the bigger number. The number of protons is the smaller number. Because remember, this is the number of protons plus neutrons. So it's going to be a bigger number than the number of protons alone. So all chlorines have 17. Now, it's probably easier to, once you're at this point, go and do the electrons. There's one more negative than positive. So what's one more than 17? That would be our electrons. Remember, it's a negative, so it has this negative slope. It's a sloping toward the -1. Oh, wow, I didn't even think of that. I actually made it. That's, if you know your math well, that's a negative slope. And then if you know your math well, that's a positive slope. So there's a little connection. Never thought of that before. That's a good way to do it. Protons on the left, electrons on the right. Stays consistent with your understanding of math, hopefully, and the slope of a line. But anyway, getting back to this, if it was neutral, if there was no charge, it would be 17 electrons. But I've got one more electron than proton, so I got to have 18 electrons. So there's one more negative than positive, and that's why it's a -1. It's more negative. Now let's deal with that rounding and subtracting in order to get the number of neutrons. Now, I don't have to round because It was given to me. Remember, we're in override mode now. We don't look at the periodic table for the mass, which is 35. We look at what was given here, which is 32. So we take our 32 and we subtract out the number of protons the way we always do. And we get 15 neutrons here. All right, so chlorine 32 has 15 neutrons. What does the regular chlorine 35 have? If it's 35 protons plus neutrons, because we round to the nearest whole number, 35.4 rounds to 35. Take your 35 and you subtract 17. And what do you get? 18. So normally the basic one off the periodic table has 18 neutrons, but chlorine 32 has 15 neutrons. See what I did? I subtracted 3 neutrons. It should have a mass of 35, but I gave it a mass of 32. So the only thing that changes with isotopes is the number of neutrons. So how do you know what you're looking at? When you look at something like this, which has no charge and no whole number for a mass, this just came off the periodic table. I could have just written it like this and asked you for the number of protons, neutrons, and electrons. You'd go to the periodic table and say, oh, it's number 11, so it has 11 protons. It's neutral, it has no sign above it, so it has to, if it has 11 positives, it has 11 negatives. And then you would go to your periodic table, you'd see it has a mass of 22.9, which is 23. When you round it, you would subtract out your protons and you would get your 12 neutrons. So you don't even need numbers, you just need a periodic table. When you see a plus or a minus above it, then you know you've changed the number of electrons from what it normally is to something different. There's a positive one, and then I did one with a negative over here. There's an ion here. So this is an ion. That's ION. This up here is an ion, ION. Then how do you know you've changed neutrons? Well, has nothing to do with the charge. It either has the symbol written with a number to the left above and the left below, or the symbol written with a dash and a number after it. For this example, you can just ignore the -1 for a second. Or I did it up here, sodium -24 or sodium 24 up left, bottom left is 11. Those are your isotopes. So plain old element or atom, ion of that atom, isotope of that atom. And that's what happens when you change subatomic particles. When you change the electrons, you get an ion. When you change the number of neutrons, you get an isotope. When you change the number of protons, you just get a totally new element. 11 and 11 are sodium, 4 and 4 are beryllium for the number of protons. What do you think? You got a grasp now on ions and isotopes and figuring out subatomic particles? This is about a 3-part series. I went into the basics of subatomic particles in the first video. I went into ions in the second video, and I did ions and isotopes in this video. I'll throw a link in the description down below to those videos. Thanks for joining me. Don't forget to like and subscribe. And don't forget, if you want more of this tutoring at your pace, at your level, or the subject that you choose, or your time, hit me up. You can either click the link in my on my channel, or the icon in my channel for the QR code, or scan it right here before I end the video. Thanks so much. See you again next time. Have a good day.